Okay, checking your work across the bottom right here. What was this whole function doing? It was decreasing. So it is decreasing from negative infinity to positive infinity. And you can either write none or n/a. Okay, y'all take your hats off. Okay, here we go. Increasing or decreasing or constant on this one. Now, this right here is an asymptote. That is not actually part of the graph. So don't think that that is what we're looking at, okay? We're looking at this curve. And what is it doing from left to right? Increasing. This is exponential growth. Okay? All right, what about number 7? It is constant over the entire graph, okay? Because it's coming from negative infinity to positive infinity. And then this last one here, once again, this dashed line that I highlighted yellow, that is your asymptote. It is not actually part of the graph. So what's happening right here? It is decreasing. Perfect. From left to right. Okay? All right, do you have any questions about that? I think the hardest part is when you're trying to like stop and start, stop and start, stop and start. The whole thing, I feel like it's pretty easy to just look at the graph and determine that. Okay? All right, hey, what you got? So yes, your y value is 2, okay? But if you're looking at the y value, so your y value remains 2 over the entire thing. So that's why I'm just going to say that this is constant. You don't even have to put the 2 in there, okay? All right, that's a great question. Anything else? No? Hey, can you do me a favor? Can you shut that and like lock it? We had to open the second period. For a particular reason. It goes down, but that's good enough for right now. It's just not as loud. Okay. Now, this is just a quick review also of our Algebra 1 stuff, okay? It says, what type of function does each of these represent? Determine the intervals of increase, decrease, or constant. Okay, so right here, if I am looking at this very first table of values right here, okay, what do you notice is happening every single time from value to value? Yeah, you're adding 4 every single time. Now, this right here is what we call a common difference. You remember those, the arithmetic sequences? That is a common difference. That's what you're adding over and over and over again. So because the first time that I found that pattern is the same, we call this the first difference, okay? If the first difference is equal. So if first difference is equal, that makes this a linear function. Okay? That makes that a linear function. Okay, and what is happening the entire time? Since I'm going up 4 every single time, this is going to be increasing from negative infinity to positive infinity. The entire thing is going up from left to right. Okay? All right, then I'm looking right here. What am I doing to get from 0 to negative 1? Minus 1. Well, then I go back to 0, so that's plus 1. Then I go up to 3, so that's plus 3. And then I go up to 8, that's plus 5. That number's not the same every single time. So I'm going to go to my second difference. Okay? Here I am adding 2. I am adding 2. I am adding 2. This is called the second difference. Okay? So my second difference is equal. So that makes this a quadratic function. That's x to the second power, okay? X squared, which is my U-shaped graph. And therefore, we should know that quadratics, my U-shaped graphs, they have an interval of increase and decrease. It's falling and it's rising, okay? So what I want to look for is the vertex, okay? The vertex is kind of like that point of change, okay? That happens right here. This is my vertex. So if I were to graph this, 2, -1, you got 1, 0, and you have 3, 0. You can kind of just sketch this right here. Okay, the left side of my graph is falling. The right side of my graph is rising. What is the value at which that change happens? At +2 right here, okay? So this one is decreasing from the left, from -infinity until I get to 2. And it is increasing right there at that vertex at the value of 2 for the remainder of the graph. So 2 is where the change happens, okay? That's the x value where it starts going a different direction. Okay? All right, then over here, what's happening? You're what? You're multiplying by 3 over and over and over again. Now, this is a common ratio. Okay? So if I have a common ratio, that makes this exponential. And because that ratio, because my R value is greater than 1, that makes that an exponential growth function, which means that my graph is increasing over the entire thing. If that common ratio was a fraction less than 1, then it would be decreasing. Okay? All right. So we got my intervals. Now, I just want to throw this out there, okay? Linear functions are anything, or x to the first power. My first difference was equal. Quadratic is x to the second power, and that was my second difference that was equal. So what if I had a quintic polynomial? It would be the what difference that was equal? What does quint mean? 5. So you would have to go to the fifth difference in order for it to be the same value that you see that you're adding. Okay? Do y'all remember what? So when I think of those polynomials, we only have special names up through the quintic. Everything beyond that is like x to the 6th power, x to the 7th power. We'll get to that. Does anybody happen to know off the top of your head for bonus points, what do we call polynomials to the 4th power? Quartic. Good job, Singleton. You're Michael, right? Look at me getting it right. I have both of you, so y'all bear with me. Okay. All right, very good. Very, very good. All right, right here, let's take a look at this. It says, if you have a parabola, what is a parabola?
The line at which each number.
Whoop, that's my asymptote. That's okay. It's my U-shaped graph, right? Okay, so a parabola is the graph of a quadratic function, okay? Parabolas are quadratic. All right, now it says it has a positive leading coefficient. That means that this graph opens up, okay? A positive leading coefficient means that the graph opens up, and I am told that it has a vertex at the ordered pair 2, -5. Now, I don't really care about plotting that on the coordinate plane. I'm just going to mark the point. It says, what would be the interval of increase? What side of that vertex is going up? The left side or right side? The right side. Okay. Now, if I am writing an interval of increase, we use our x values, okay? I'm going to put a caution sign here, and I'm going to say, use x values, okay? My x value is 2. So, my interval of increase, 2 to infinity. Or you could say where x is greater than 2. Either way is fine. Okay? The next one, I have a parabola with a negative leading coefficient. That coefficient tells me how it opens. So if it's negative, it's going to open down. Good. Okay. And this one has a vertex at the ordered pair, -7, 4. What would be the interval of decrease? What side of the parabola, or what side of the vertex is falling? Still the right side is going down right here, okay? So here I'm going to say that it is decreasing from the x value of -7 to where? I told y'all yesterday that was going to be a common mistake. I'm moving from left to right, yes? My x values, what's all the way to the right? My positive infinity, yep. It is pointed down, so that is going to be a common mistake that we're going to want to write. It goes down to that negative infinity. But that is the end behavior. That's where you're telling me what direction the tails are pointed, okay? I want to know from left to right, is it rising, falling, or flat? Okay? Common mistake. I'm going to put a caution sign right here, and I'm going to draw an arrow. Okay. All right. What do you notice about the intervals of linear functions? Linear functions are what? It's going in one direction, right? So it's either all increasing, all decreasing, or all constant. What do you notice about exponential functions intervals? Exponentials are exponential growth or exponential decay. They are either all increasing or all decreasing. Will you ever have a constant interval on an exponential? No. Unless it's just that asymptote. But that asymptote, we're not really like, we're just pretending that's our imaginary friend. Okay? All right. What about quadratic functions? Okay, so it's always going to have one interval of increase and one interval of decrease. Okay? Perfect. So just make sure you remember that about the 3 function families that we have focused on since Algebra 1. Okay? We will learn new function families this year. Very soon. Okay, positive or negative? Positive or negative? I need for you guys to have a green and pink highlighter. or a green and red colored pencil, whatever you got, okay? Okay, positive or negative? Okay, positive numbers are on the what? The right side of the graph, but yeah, okay, hold that thought. If I'm thinking about a number line, it's on the right side of what? 0. And my negative numbers are on the left side of 0. Okay, positive or negative on the coordinate plane? Okay, positive or negative on the coordinate plane? When we are identifying our intervals where a graph is positive or negative, we're going to be looking at the y values. Okay? So when we identify positive and negative on the coordinate plane, I am going to write it according to my x values, just like I did before. Okay? But if I am identifying my positive and negative values, I'm going to be looking above the x-axis for positive. Okay, this is above the x-axis. Okay. Below the x-axis is the negative, okay? All right, so above or below the x-axis. Now, what do you think I might consider the x-axis itself? All right, that is 0, right? So is 0 positive or negative? No. So this right here, the 0 is kind of my neutral zone, okay? So this is never going to be included in anything. So if it's neutral, that means it's not positive or negative. You can't see that, I'm sorry. It is neutral. It is not positive or negative. So that means you will always use parentheses, or you will use the less than or greater than when I am specifically like talking about a number on the x-axis, okay? So, not included. 0 is neutral, okay? That has a value of 0, and 0 is not positive or negative. So when I am identifying my intervals, you will never include the number that I'm referring to on that x-axis, okay? All right, y'all have that? Okay. All right, so let's take a look down here. Okay, and let's talk about some of the things that we know. let's think about the easy things that we know. What type of function is this? Is linear. Okay? Now, because I spent time earlier writing the equations of lines, I want to do that. You need two things to write the equation of a line. You need the slope and you need the y-intercept. What am I doing to get from point to point here? Yeah, rise one, run one. And where does it go through the y-axis? At 0. So my equation here is just y equals mx or 1x plus b, which is 0, yeah. So I'm just going to leave this alone. That is my equation of the line. Now, is this graph increasing or decreasing? It is increasing from negative infinity to positive infinity. Not only does this one have a y-intercept at the origin, it also has an x-intercept at the origin. So you could say it hits at x equals 0. Okay? You could also, typically, when we are talking about intercepts, we like to write those as ordered pairs. Okay? But specifically, it is hitting right here at 0. This is the value where it hits. Okay. This is where I'm going to use my highlighters. Okay? It asks me, where is this graph positive? That is going to be every part of that line that is above the x-axis. And it is negative every part of that line that is below the x-axis. Okay? Now, we use our x-intercept to help us write these intervals. Okay? From left to right, my graph is going from negative infinity to positive infinity, and the graph hits at 0. Now, I would say that it is negative from negative infinity to 0. And I would say that it is positive from 0 to infinity. Do what, babe? Oh, you're okay. Now, another way that I can say this. It is positive when my x values are greater than 0. It is negative when my x values are less than 0. Once again, my x-intercept is what I'm using to help me write these intervals. Okay? From left to right. From negative infinity until I get here, it's negative. So everything that's less than 0. Here, the rest of it is positive. Everything greater than 0. Okay? Flip it over. What type of function is this one? Exponential. Okay? Now, I'm not as good at writing the exponential graphs. I do know that there is an asymptote right here on the x-axis. Okay? Now I'm going to say that the asymptote has an equation of y equals 0. What is this graph doing from left to right? Increasing or decreasing? It's what? It's increasing, okay? It's increasing from negative infinity to positive infinity, the whole thing. It looks like it's going to kind of level out there and be constant, right? That's what it looks like. But mathematically, we know that the graph is going to get closer and closer and closer to that line. We can always add another decimal, right? All right. Now, What is the x-intercept here? There is none. Remember, that's where my asymptote is. That's my MC hammer line. Why do I call it that? Because you can't touch it. Yep.
Can I put NA as an answer there?
Sure. Yeah, none or NA. Either way. Okay. Where is this graph positive and where is it negative? All right, so let's think about this. I've got an asymptote right here. Is my exponential graph ever going to go to the other side of that asymptote? No. The asymptote is on the x-axis. So the entire graph, friends, is positive. So it is positive from negative infinity to positive infinity. And this one will never, ever be negative because it can't cross that asymptote. Okay? Anybody need me to hold tight? Okay. This is a what kind of function? Quadratic. Perfect. Now, we know that quadratic functions have a special point. Okay? Now, that has a vertex. Now, it's kind of off-centered. I'm not going to worry about that. But we do know that we could just say that this is the vertex, right? Okay. Thankfully, I'm not worried about where it's doing what. I'm not specifically asking from or where is it increasing, where is it decreasing. I know that it is falling, and then it turns and it rises, okay? So it does both, okay? From negative infinity to the x value of the vertex, it is decreasing. And it is increasing from the x value of the vertex for the remainder of my graph to the right. It's a decimal. I'm going to say that's probably negative 0.5. But I don't know that for sure, so I'm going to leave that alone for right now. Okay? All right. This asks me, what is the x-intercept of this graph? So I'm going to come and I'm going to mark any place that I see this graph cross the x-axis. This happens in two places. So I have two x-intercepts. What are they? Negative 3 and positive 2. Yes. Say that one more time.
I'm listing it out under that squiggly line, like where you put our x values in.
Oh, you talking about like we did domain range? Yeah, that's fine, because that's a set of solutions. Okay. All right, here we go. From left to right, I am asking, where is this graph positive? I'm asking, where is this graph above the x-axis? Well, it is above the x-axis right here and right here. And it is below the x-axis from here to here. So there's some change happening, right? It's positive, then it's negative, then it's positive again. Do y'all see how this is a little bit different from increase, decrease? Okay? Now, we write these intervals from left to right. So we're going from negative infinity to positive infinity. Well, changes happen at negative 3 and at 2. All right, now watch this. I'm going to bring all those values from left to right. I'm going to say negative infinity, negative 3, 2, and infinity. I'm going to write that from left to right, least to greatest. Okay? What is happening from negative infinity to negative 3? Is it positive or negative? Is positive. Then it goes underneath the x-axis from negative 3 to 2. And then it goes above the x-axis again. So these are my intervals. From negative infinity to negative 3, it's positive. From negative 3 to 2, it's negative. And then again, from 2 to infinity, it's positive. Writing it out like this, okay, when we get into our pre-calculus stuff and we're trying to identify positive, negative, or intervals of increase, decrease, or all the different things, I like to write my important values out, and I like to put symbols, or we're going to have to write intervals of concavity, okay? I like to write my important numbers out and then draw my shapes, okay? Okay, here we go. Shading and identifying positive and negative. First thing I would do on any graph you've got, go mark any x-intercept. So here's an x-intercept. You got this. Now here is negative 1. So I'm going to say this is probably negative 0.5. And this is 1, 2, this is 3. I'm going to call this one 1.5, that first graph over here. I'm just going to write those values, okay? I'm going to call this one negative 2.2, just because I'm estimating, okay? That one already had those marked down here. I'm going to call this one 0.8. Are you okay with that? I'm just estimating. That way we all have the same numbers. An x-intercept here, that happens at negative 4. Do I need to mark this one? Y. What is that? That's a y-intercept. Yeah. I only care about my x-intercepts for this. So I got negative 2 and 1 here. Okay. I'm going to go look at my directions. I've marked all of my x-intercepts, okay? This first one says shade the positive region. The positive region is the part of the graph that is above the x-axis. So right here. Here and here. Here. And then this part right there. Down at the bottom, it asks me to shade my negative region. So that would be anything that falls underneath the x-axis. So that's going to be there, here and here, here, and here. What's wrong? That's okay, because you should have different colors, okay? If you do go ahead and you shade all of them, the different colors, if you did pink, 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 green, 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 just know we're going to write the intervals of what's asked. Yes? Can you hold on just a second, or is it emergency? Okay, all right. Give me just a second. I'm almost done with content, and then I'm going to give y'all time to make sure you got everything turned in since I sent that message out last night, okay? All right. It says, what is my positive interval? Right here, remember, I'm going from negative infinity to positive infinity. My positive interval starts at 1.5 here and goes to infinity. You can write it like that, or you can say here, it's everything where x is greater than 1.5. Okay? Right here, my positive intervals. I have 2 of them. It is positive from the left, so from negative infinity until I get to negative 0.5, and again from 3 to infinity. Where is this one positive? 0 to infinity. Perfect. And this one is positive where? Negative infinity to negative 2.2. You want to know what I've seen in the past? Positive infinity to negative 2.2. Because they think, oh, it's up here. But we got to remember, we're reading this and writing this from left to right. Okay? All right, down at the bottom, shade the we shaded the negative region. Now I want to write the negative interval. Okay? What do I say here? (0.8 to infinity). What do you think my common mistake is here? People put to negative infinity. Okay, I'm going to put a caution sign here. You should have a caution sign on your notes because I don't want you to mess that up, okay? All right, what about here for this one? I've got 2 negative intervals. Union 2 to infinity. Excellent. Okay. What about this negative interval? Negative 4 to positive infinity. It's the right side of your x-intercept. Okay. And then what about this one? Negative 2 to 1. Okay. So, intervals of increase, decrease, constant can very, very easily be confused with writing these intervals, okay? Pay close attention to your directions and what is asked of you, okay?